In this MATLAB and Simulink tutorial, I want to demonstrate the following things. How to define a scalar variable in MATLAB script so you can use it in Simulink. How to define a vector variable in a MATLAB script and then access it in Simulink. This is specifically, in my case, for the purpose of providing stimulus to the Simulink model. So maybe I have some time domain waveform that I want to drive the system with, and I don't want to use one of the signal sources in the Simulink library browser. I want to just define it programmatically. 3, in case you've never used an anonymous function, which is probably the most intuitive type of function that you might think of using, like I just want to define f of x and use it. I'll show you how to do that because we'll make use of it as we go along here. Number 4, once you have run a simulation in Simulink, how do you take the data from Simulink and return it to MATLAB so you can plot it or so that you can further analyze it? And then finally, how do you publish your MATLAB session using the publish functionality, including how to output figures and how to include a graphic of your Simulink model. So what I have here are two files. I have a test.o.m file, and I have a Simulink model here, which I've called test1.mdl. Notice I've named them different file names. MATLAB has a problem with having two files of the same name but with a .m and a .mdl extension in the same folder. It doesn't like that, so I have to use two different file names. The system I'm simulating is very simple. It's a first-order system. I've input a transfer function 1 over s tau plus 1. Tau is the variable that I need to define, or the scalar I need to define in order to run this simulation. I am driving it at the input initially with the step function, but I've put in this manual switch because later I want to switch it over to my own generated stimulus that I'm going to programmatically generate within the MATLAB script. That's this block down here. And then in order to output or take this data that is generated from running the simulation, excuse me, and accessing it back in the MATLAB script, I need to send the data of interest back through these output symbols called out. They are found on the sync category in the Simulink library browser. Okay, so and then finally I've combined the input and the output and fed it to the scope so we can look at the result. Okay, so usually when I start a script, I always clear the screen, the command window, and I clear all the memory as well. Here's where we define our system parameters. The time constant, because it's a mechanical system with a mass and a viscous coefficient. The tau, the time constant, is just mass over viscous coefficient. I've defined that here. Once I run the script, tau will be in memory, and if I run Simulink or a model in Simulink that references tau, it will have a value associated with it. I am going to use in a little bit a step function. I don't know if MATLAB has one built in, but I decided just to make my own. This is how we define an anonymous function. The reason it's called anonymous is that MATLAB's standard is that when you define a function, you actually place it in its own .m file. So if I were to call a file u.m, and I included that file within the path of whatever of my MATLAB workspace, then I could actually then use, or I could make use of a function called u, and call u of 1. And when I did that, it would actually go to that script file called u.m, and in there it would expect to find a definition for the function u. In other words, the name of the file is actually the name of the function. But they do give you a provision for being able to have what they call anonymous functions. These are the simple functions that are going to reside within a script, in the same script where you're going to use that function. And that's what I'm doing here. I don't want to have a separate file that I have to lug along. So I've defined it here. The syntax is very simple. It's the name of the function, in this case u, and you say equal, and then you always then follow it with an ampersand, and then in parentheses you list the arguments. In this case, I just have x. If I had two arguments, I would do x, comma y, x1, comma x2, whatever. Space, and then this is my function definition. GE is greater than or equal. It's a built-in function that MATLAB has in its Boolean class, and all I'm doing is I'm going to return the value of greater than or equal to, basically evaluating is x greater than 0. If it's greater than 0, then return 1. If it's not, return 0. So this is a step function. And I'll use it here in a moment. So now I want to define a time domain stimulus to drive our model. And I begin by defining time. So here's just a series. It starts at 0, step of 0.1, it goes to 20. So this will have 201 elements. Okay, but if I type it in, let me type it in down here, t equals 0, 1, I'll just go to 2 to make it short. Okay, it is a 1-row, 21-column array, and I can double check that by typing who or whose, and whose tells me all the variables and functions that are in memory. So t is a 1 by 21, so 1 row by 21 columns. In order to pass it to Simulink, Simulink wants a 21 by 1. It wants a single column. So I need to define t in this way. I need to use the transpose with a single apostrophe. And now I will have 21 by 1. So be very careful here. Don't overlook this apostrophe. That transposes it. Next, once I've defined t, anything that I use, any expression or follow-on variable that I define that uses t will also have that same dimension. Well, or a dimension derived by it. So for instance, if I say x is equal to 2 times t, well then x now is also 21 by 1. If I said x was equal to 2 times t, okay, now I have a problem, and that's because the multiply operator is defined for matrices, and I'm trying to multiply a 21 by 1 by 21 by 1, so I can't do that. Now I could multiply 21 by 1 by let's not do that. Let's do a 1 by 21 by 21 by 1, and that would give me a scalar value. But what I really want to do is I want to multiply each element in the first array times each element in the second array, and for that, MATLAB has a syntax where you prepend the operator with a period. So now I see that x is still a 21 by 1. In fact, if I want to plot this, just to make sure that this is in fact a quadratic, I see in fact that's what it is. So what I have done up here is I've defined x to be, I guess I got ahead of myself. You'll see down below here that I used the multiply, and here I have the period multiply. So that was getting ahead of myself. But here we are back trying to define a time domain stimulus for our Simulink model. What I want is a step function. Actually, I want a pulse. I want it to step up. I want it to be 0 up to time 2, and I want it to step up to 1 between 2 and 22, and then back down to 0. So since I've defined my step function u here, I can make use of it in defining x. And I say x is equal to u of t minus 2. So there's going to be a step that starts, that steps at time equal to 2. And stay at 1, but then at time 12, it's going to subtract 1, so I'll be back at 0. So this is what I'm going to use to drive my Simulink simulation. And to define that within Simulink, what I need is I need to input, or I need to add a signal source that is from the source palette, and it is called from workspace right here. So I've dropped that in, and double click on that, and you need to define what the data is. There are multiple ways to define this. You can see up here they give you a more general form, but we don't have to employ that here since we're only dealing with a single data string, just a single, just a dimension of 1. Okay, so it's just x, not x1, x2, x3. We can define it as basically this becomes a, instead of being a 21 by 1, when I do t comma x, it'll be a 21 by 2. And MATLAB or Simulink expects the first column to have time, and then the second column to be the data. Okay? So I'll click OK on that. Another thing that's important is, okay, sample time. These are defaults. I didn't mess with anything else here. These are all defaults. So that's another good thing to know. Okay. Let me switch this over to here. I won't even run the step now. Let's go back to the model. So here this is where I've defined my time domain stimulus. I'm good to run the Simulink model now. Next, what I want to show you is how to. Why is my cat here? Hold on. Okay, back to this. So one of the other things I wanted to include here was, besides running a Simulink model and then gathering, or returning the data from the Simulink model back to MATLAB, which I've yet to show you, I also wanted to actually generate some data within MATLAB. So here I have some input, some load, and I'm stepping it from 0 to 1. And I'm defining some output y, and it happens to have some functionality that's related to load. I made it load times 1 minus load. Notice here's where I have that period times. And I'm showing two different ways to generate this. Y1 here I've defined as a anonymous function where I pass it a load, a variable LD, and the definition of the function is LD times 1 minus LD. So in the first case here, when I actually evaluate this, y will actually be populated with numerical values. It will be an array. It will be a, what would that be? A 11 by 1 array, because there's 11 elements in load here. In the second case, y1 is just a function, so it doesn't get assigned any data until I actually pass it, say, an array of loads, and then it will return an array. Okay, and I want to plot this. So in the first case here, I'm actually plotting the load versus y, and I guess I didn't use it here, but I could have just as well typed in y1 here, and y1 of load, and then I would actually be evaluating that function as I passed each value to it. This will generate a plot. It has nothing to do with Simulink at this point, but the idea is that if that Simulink model represents, is a physical model that for which you want to predict or study a time domain response, you might also want to study something about that same system statically, not dependent on time, and you may do that programmatically within MATLAB. And so that's what I'm showing here. Now we arrive at the place where we're going to actually set up our simulation, our Simulink model from the script, and then actually run it from the script, and then gather data from it. Okay, we're now ready to configure and run our Simulink model. So this section here is probably the most, I guess, confusing, but you can just copy much of this. So there's some comments here that help. This first section I'm going to ignore for the moment. It has to do with how to generate a graphic of Simulink and to output it and publish for MATLAB, so we'll come back to that. This next section has to do with configuring the Simulink model. So the main thing that we need to accomplish here is we need to get a handle for the output data. We need to tell Simulink to actually save output data. And so what we do is we define a variable name for our model, test1.mdl. You don't put .mdl because it's simplified. And then this function here gets the configuration set, basically a pointer to the configuration, and we're going to actually turn around and manipulate some of the parameters there. This next line is not necessary, but it returns a list of all the parameters that are available. And if you type this in the command window after you run this, it'll list just, I don't know how many, maybe hundreds of parameters that one could set. It's a little intimidating. Okay, from here on, we're going to define some parameters. Param name val structure. Struct is just a variable that we're beginning to use, that we're defining. And so it's going to be a structure with some data members to it, or a class with some data members to it. And I don't know if all of these are necessary. The mode, this has to do with some relative tolerance. You can choose to leave these things off initially. What's really important, though, is to save the time. So you want to set save time equal on, and save time, and time save name to t out, and save output to on, and output save name to y out. These are important. The state names, I didn't use those, but that would be good too. You can actually, this will hold all the values of your integrators in your Simulink. So even if you don't output them to some, if you don't route the signal to some output bubble, like I showed you, then I think they're still saved. In this example, I only used the y out and t out. Okay, so we populate this param name val struct, and then this is the key statement right here. We're actually instantiating or starting the simulation. So sim will actually run the simulation, and it's going to run our test1.mdl, and it's going to use this configuration structure to run it. Okay, so we pass these parameters to it to actually run it. Now I recall I had done this a while ago. I think the reason that I got this get param object parameters is that these names here, reltol or save output, these are important. These are not arbitrary names. So these have to be parameters that are actually part of the parameters for Simulink, and so the way you can check that one way is to just list all this out and kind of look through it. But once you know what to use, you don't actually need to, you wouldn't actually have to use any of these. And my guess is all of this can be left off for now too. So we're going to run our simulation, test 1, and we're going to pass these parameters defined here. And the results of the simulation are going to be returned to sim out. So at this point, we just need to collect our data. So we say y out is equal to, and this we could call it anything, but I'm calling it y out, is equal to sim out get, and then we're going to extract from sim out, we're going to extract our y out data. Okay, so this y out here has to match this y out over here. And now we're going to get time. I call it mt sim out get, and here we're going to get t out, which has to match with t out right here. So now we've got our outputs. This will be as many output bubbles as you have will be the dimension here. Since I know in my example that I have 2 of them, I'm going to extract the individual ones here. I'm going to call it the first one y is y out colon comma 1, second one y out colon comma 2. And then I'm going to combine them together into one variable. I'll call it m out. And the reason I'm going to do that is so that I can just plot them together right here. So I'm going to plot them both against time, and I add a legend in. Okay. So when I run this plot here, I will be actually plotting data that was generated from Simulink. Now lastly, I want all of this to be automated and to be basically to be published. Okay. So there is a function actually an icon here that helps you do this. You click under this right by the printer. It's called Publish. Hover over here. It says Publish testo.m. When you click this, it's going to basically run the model, do everything the model does, but all the output will ultimately be output to an HTML format. Now there's special markup syntax that can be used to make that publishing look prettier. You might have noticed that some places I've used 2 ampersand signs, and it actually makes things look a little bit differently. I get this coloration, these blocks. Okay, and I would just encourage you to type doc publish, and I think that might be the thing you want to type, and it'll bring up. Okay, maybe that's not what you want to type. Maybe just publish. Well, yeah, so right in here, and they have some examples. Well, that's not exactly what I wanted. I want to go to, I'll tell you where it is. Under MATLAB User's Guide, Desktop Tools and Development Environment. And you go right here to Publishing MATLAB Code. This is what you want to look at, Overview. And in here, there are there's examples. Lots of examples. Okay, so I would refer you there. But let me just show you where you can find some useful markup commands. So in the cell, there's an insert text markup. And in here, there are a number of things that you can put in. You can actually make equations format nicely. You can input an image, which is exactly what I have done. Put links in. So let me show you where I did. I put in an image. I was right here, and I just clicked cell insert image, and it drops. I just did it again. It just dropped this thing right in here. I'm actually going to undo it because it put it in twice. Okay, and then I just filled this piece in here. I had to tell it what I wanted to load. Okay, one important thing you'll want to know, note that I just recently figured out, is that every time that you make a plot, so let's see here, here I do a plot, you want to put the double percent signs right in front of that. If you don't, and let's say you have 5 plots, and you don't put this in front of any of them, then only the last plot will actually be published. The other ones won't. Okay. All right. So there's really not much. I didn't do much to mark this up. I could do a whole lot to make it look pretty, but I've done really very little. The only thing is to put these dividers in periodically, where I put in a %. As you'll see from the publishing, the nice thing is wherever it has this and there's text next to it, it'll actually put a table of contents at the top with a hyperlink that actually goes to that portion of the output. So it's very nice. So here's this this part that will help you to, or enable you to be able to include your Simulink model graphic into your publishing. And there might be a better way to do it. This is my way that I figured out how to do it. So one is you can change the orientation. Test 1 is the name of your model, of the Simulink model. Okay, you can change the orientation of your model. Usually it's landscape, and you need to turn it portrait. Trust me, if you don't, it's going to be the wrong orientation. And then the way I do this is I actually print the Simulink model or image block diagram out to a graphic file, and then I'm going to load it back in. So this is the print statement. -D is the format. It's a JPEG. -R is the resolution. You want to leave it like 100 because otherwise it will make it way too big. -S is what you're printing, the model that you're printing. So this is actually Simulink. That's what it is, Simulink. And then the model name. And then here is the file. ./ is supposed to be the working path. I thought it would be the path or the folder where this resides, but it turns out for me it's up at the very MATLAB, the top level here. So you'll have to play around with that a little bit. At this point, it will actually save a JPEG of your Simulink model, and then here I do the cell insert text markup, click on image, and in here I put in the path, and I thought I could just put in the same path as this, but it did not work for me, so I have put in this entire path length, and it works at this point, though I'm not pleased with it. So I think I've shown you everything now, and yet you've seen nothing. So let's run this and watch how this just all auto-generates. Assuming I didn't add an error. Now I didn't put pauses after my plots, so it kind of goes from one thing to the next. Typically, if you're not publishing, you want to put like a pause statement after your plot so you can see them. But here is the output of our publishing. Okay, let me scroll down, and you'll see all of the everything that's in our script, except where I had the %%. You see it bold like this, and you also see that it's hyperlinked up here, which is super nice. As we scroll down, here's where I had a plot. Now I put an ampersand or %% and in front of the plot, and so I got my plot output. And then my Simulink model, here's where we printed it to JPEG, and then here's where I inserted the image. And so now we see our Simulink image. I'm very proud of myself that I was able to figure that out. I got a little help online with knowing about the print. I have to admit that. And then here's where we run our Simulink, or configure our Simulink. Here's where we run it. Here's where we extract the data that came back. And then I'll give you some warning about the step size, but here's where we plot it. So here's the result from our Simulink. Now just to make sure, or to validate that that's actually what happened, if I go back to my model and I click on here, come on, I see this open up, and this is the same result as this right here, right? So you see, in one click, I have not only a functioning Simulink and MATLAB file or model, but it was output very nicely to HTML. And so I can print this, and this, for some reason in my case, I don't know why, it goes to Word. But, not to fear, you can just copy this URL and go over to your browser, paste it in, and then like print to your PDF output or something like that. I am interested in what it said. Oh, it printed it. It actually used Word to print it to my default printer. So it might be showing up over in my office on campus. Alright, well that wasn't as quick as I thought, but I guess there was more information in here that I needed to show you than I expected. I will post, try to make available this test0.m and test1.mdl so that you can play around with this. And I thank you for watching.